Deep in the Antarctic ice, scientists search for neutrinos, a nearly massless subatomic particle that springs from the most violent astrophysical sources. Exploding stars, gamma-ray bursts, and cataclysmic phenomena involving black holes and neutron stars. The South Pole's Ice Cube Telescope is a powerful tool in the search for dark matter, with the potential to reveal the enigmatic origins of the highest energy particles known to humankind. And doctoral student Emily Dvorak has a front row seat, working at the Ice Cube Experiment's headquarters in Madison, Wisconsin, with the largest neutrino detector in the world.
We cannot create neutrinos of this energy here on Earth with any of our current running experiments. And to determine more about the universe and the matter in the universe, we need to discover more about the elementary particles that make up the world we live in.
A mile underground in a clean room at the Sanford Underground Research Facility in Lead, South Dakota, Cabot Ann Christofferson is on a similar pursuit. Christofferson produces the ultra-pure copper for the Majorana demonstrator, whose parts are all born and machined 4,850 feet below the surface to ensure a radiation-free environment. The ultimate goal? Look for the elusive neutrinoless double beta decay, proving the mass of the neutrino and why it changes flavors. Essentially, why we all exist.
The copper is a process that's not new. In a sense, we're electroplating, but what we do is electroforming, which is extremely slower, and we are doing it in a specific manner so that we literally lay down atom upon atom layer so that we exclude all other contamination that could give background when the detectors are running, searching for this neutrinoless double beta decay. So in this lab, we have 10 large baths. They each hold 1,800 pounds of extremely pure copper nuggets that were extruded under argon. We then dissolve them and purify them even more. And the copper that comes out of this lab is the purest copper in the world. It is so pure that to extrapolate this the purity of the concentration of the copper, we have to look at what is excluded and left behind in the baths instead of the actual copper itself.
The process is constantly evolving. Working under Christofferson, one graduate student is researching the production of new alloys with even better shielding capabilities and lower contamination. Eventually, her work will move underground, offering a rare, real-world application for graduate research on an experiment that brings together 100 scientists from around the globe.
So I think your opportunities are just what you make of them. You'll have tons of time to take different approaches or different opportunities in different locations, and you should never be afraid to take those chances. Because anything you do, graduate school is going to be an experience that's going to better your options later on.
That's certainly been the case for Mark Hanhart, whose doctoral work on nuclear astroparticle physics has landed him a career with LUX, the large underground xenon detector at Sanford Lab. LUX looks for the dark matter particles, dubbed weakly interacting massive particles, or WIMPs. Thought to comprise more than 80% of the matter in the universe, WIMPs have yet to be directly detected. But for Hanhart, the mere chance to study the universe at this scale is transcendental.
There's certainly an art to what we're doing, and I mean there's a deep philosophical love of art to it. There's a poetry to the universe, and that is spelled out in its fundamental laws and in its mathematics, and that's something that we strive to study here. That's something that we really try to understand, and bucking the idea that physics or any science is this cold, methodical, pure calculation kind of based field is wrong, because it's really about pushing yourself to understand everything on a truly elemental level, to actually peel back the layers of the universe and take a peek inside. And again, I can't imagine doing anything else. I can't imagine anyone wanting to do anything else. I'm going to try not to actually unplug anything.